little bit of different stuff, but something maybe you've seen before. All right, somebody answered this first one already, a 6. Absolute value negative 6. What about this one? It should be a negative, negative 6 minus 3, which is a negative. Absolute value of negative 9. Absolute value of negative 9 is 9, but it stays negative. So negative 9, very good. What do y'all have on this one? 1 minus a negative 6. The absolute value of that plus 4. That would be the absolute value of 7 plus 4, which is 11. Very good. What about this one? We got some discrepancy. I don't know. Negative 6 minus 1 half more. This would be 2 times the absolute value of negative 7 and a half. Is that all right if I skip that step? Plus 0.5. Well, what's the absolute value of negative 7 and a half? 7 and a half, right? Times 2 is 15. So 15 plus 0.5 is 15.5. Sure. Last one. What do y'all got? Negative 7. So negative 3 times the absolute value of negative 6 plus 4 minus 1, which is negative 3 times a negative 2 minus 1. Absolute value of that is positive, but negative does make negative 6 minus 1 is negative 7. Very good. Raise your hand if you used your calculator for these expressions. Did anybody put these expressions into your calculator and just let the calculator do the work? You got 1 hand, 2 hands. Well, you get about a 2. Anybody with 3 hands? Anybody aware to have about 3? 3. Anybody in the back row now? 3. Sold it at 2 hands. All right, that's all. Y'all didn't know I was an auctioneer once upon a time, did you? I did a lot of stuff over the years. All right, turn the page. Turn the page. Today we're going to be looking at absolute value functions. You might have seen these guys before. And an absolute value function, we're going to investigate this just a little bit so you can understand it, comes from this form, mx, absolute value mx plus b inside, plus c on the outside. And if you look on down, there's actually, this is circle this form right here. This is the overall form. It has an A there, it has an M there, it has a B and a C. A lot of stuff that could be involved in these that could potentially adjust the function. Also, this very first one right here, y equals the absolute value of x. Identify that as the parent function for me. We will always talk about parent functions. We like to know where the baby functions come from. They've come from the parent function. Would y'all agree that sometimes these two over here, don't they kind of look like this guy? Like, hey, there's daddy over there. That's their parent. And anything that looks like that, it's just a translation or it's an adjustment of that parent function. All right, so let's take this graph right here, for example. Algebra 1 year. You guys spent a lot of time with y equals x. Somebody tell me, what does the line y equals x look like? How would you describe it? This is the equation, y equals x. It can be visualized on a coordinate plane. How? It is a straight line. It's linear. Very good. Where is it? 45. I like that. What's its slope? What's the number here by the x? 1, which means rise 1, run 1. You end up with a 45, don't you? Where does it cross the y-axis? There's no y-intercept, so it goes to the origin. So will y'all be all right if I just say, hey, see if I can do this. That is y equals x. Y'all agree? And that would be the parent function of all your straight lines that you did in Algebra 1. Y'all fine with that? And from there, you might have got flatter, you might have got steeper. And then also, those lines could be raised up. They could go downhill like that, right? There's all kinds of things that could happen based upon adjustments to that original equation. I'm gonna erase this now. So today, what did we say the parent function is? Y equals what? The absolute value of x. So follow this right here. We'll look at it a different way in a minute, but this parent function starts and I don't know if I'm doing that very well. My eyes get crooked looking at all these lines. Here's a good way of thinking of it. If I was to put 0 right there, what do I get right here? 0. So on a t-chart, you get 0, 0. You agree? If I was to put 1 in right here, what's the absolute value of 1? 1. So I would get 1. That's where you get that point from. 1, 1. You all right with that? If I was to put -1 in right here, if I was to say, what's the absolute value of -1? Also 1. That is why you see this kind of graph. As you get negative inputs, you're still getting positive outputs. You fine with that? Okay. Now, from that parent function, right there, from that, that's horrible. How about that? From that original parent function, what do you think would happen to it if I put a +2 on the outside? Somebody said up to it, right? Y'all fine with that? The whole thing would be raised up to. That's how you'll anticipate. What if there was a -2? Yeah, it's pretty easy to anticipate. Every output, you would subtract 2 from it. Take your input, and then you subtract 2, and you get your outputs. Be 2 less, or 2 more. Y'all fine with that? What if instead of something on the outside of the absolute value bars, what if we did this? X minus 2 on the inside of the absolute value bars. What do you think would happen to this parent function if you had a -2 right there? It would go over. Which way, right or left? Left? Incorrect. Think about it. Let's just test the number right here. Let's put 2 in. What's 2 minus 2? 0. The output is 0. So your vertex comes over here. Let's put 4 in. What's 4 minus 2? 2. -4. What's -4 minus 2? See it now? It's way up there. So numbers on the inside of the absolute value can adjust your parent graph. You follow me here? Numbers on the inside would adjust it left and right. If I had a -2 there, which typically you don't trust this sign, the one that's in with your absolute value bar or inner parentheses. Now, let me say this, guys. We'll do lots of functions in Algebra 2. And we'll talk about a lot of parent functions. And every function we look at, you typically never trust anything with your x. I know some of you boys have a couple ex-girlfriends already. If your best friend started dating your ex-girlfriend, you wouldn't trust them. Like, hey, wait a minute, that was my girlfriend. Now you're dating them. I don't trust you. So say this with me. Say this with me. Don't trust anyone, or excuse me, anything, any sign with your ex. Easton, we don't do that. So typically, if it's minus, it's actually meaning go the other way. Now, these absolute values do have one exception to that. Most of them don't. And then, if there's something on the outside, you can trust that. That will tell you the vertical translation of this parent function. Okay? There is a little bit more. Remember the formula had an M right here? So what do you think would happen? Let me get rid of this, start over here. What do you think would happen to this guy? There's our parent function. If by the x you had a 3. What do you think it would do to this graph? Steeper, yeah. Steeper lines. So it would look, that's actually the slope. So you could go from this point, go up 3 over 1, up 3 over 1. Same over here, up 3 over 1, up 3 over 1 from there. So it would be a much steeper line, and it's safe to say this here. We actually use the terminology fatter or skinnier. Is that skinnier or fatter? Skinnier, because the lines are, you got a larger slope, a slope greater than 1. It's going to make it rise quicker, steeper lines to be a skinnier graph. You okay with that? So if instead of 3, if it was 1/3, then it would rise 1, run 3. Rise 1, run 3. We would have a what kind of graph? This is the 1/3, this is the 3. Say it. We would have a what? Fatter, big, fatter, plumpier, wide, babe. Yeah. You guys are crazy. So that number right there, by the x, can adjust what kind of graph you had. Cool with that? Okay. There's more than that. We're going to look a little deeper now. There is a little bit more to the vertex. If you look right here, look closely. Let's zoom in. This is where you got to really pay attention. Most of them you can just shift them left and right, up and down. This one has a little bit more. Take a look right here. Where's this one's vertex? How far to the right? 2. Do you see an x minus 2? No. Wait a minute. I was expecting 2. There's a little bit more. We'll talk about it. Right here, look at this vertex. How far to the right? 3. Is it 3 over? Is it x minus 3? Yeah. How far up is the vertex? 3. Is it 3 up? Yeah. We can trust this 3. Oh, look at there. Minus 3. We went 3 to the right. So why could I go 3 to the right here, and then over here it's different. It's not 4 to the right. There's this little formula right here. Understanding the vertex, the x and y of the vertex is this formula. It's negative b over m. So when the m, that's this number right here, when the m is something other than 1, it adjusts the x coordinate. So when the m is just 1, you just go over 3, 3 over 1. But in this case, it's 4 over 2. See the difference? I've had a class all day of yawning children. You guys need to get to bed at night better. So there we go, 4 over 2. So label this negative b over mc as your x and y. Label that in your notes. If you see I wrote something down, you write it down. I don't write this stuff for my benefit. You need to write it for your benefit. It's not for me, it's for you. All right, so you would anticipate vertex there. Now the other things you can expect. So that'll be the vertex of the graph. The graph will be V-shaped. It will always open up if A is positive. That's the very leading value. You might notice all these opened up because there was never a negative sign in front. But if A, it'll go down if A is negative. So write this as an example. Y equals negative absolute value of X. If there was a negative sign in front, then you would expect that line to flip and open down. Come on, take good notes. If you're having trouble keeping your eyes open, take good notes. That's a good self-tip there. All right, so the A, that number in front, can also affect your graph. How it affects your graph is the graph is wider or fatter if A is less than 1. So it's kind of the same deal. Anytime it's less than 1, like a fraction, you rise less, run more. And then if A is greater than 1, it'll affect your graph and make it narrower or skinnier. You'll see that on a homework question today. You will see A, so you might put a star by number 3 and 4, because you will see this little thing make a difference on your graph, what A does, whether it's greater 1 or less than 1. All right, so flip the page. If we look over here, before you look at anything, tell me, answer some things for me. Will this have a horizontal shift? Will there be a horizontal shift? Yes, there will be a horizontal shift. Will this absolute value graph open up or down? Up. Some basic ACT questions, just understanding how to look at these graphs. Will this shift right or left based upon what you see? Do you think it'll be right or left? It'll probably be left because you'll do a negative B over M. So negative B over M would equal negative 12 over 3, so negative 4. So your x coordinate is probably negative 4, isn't it? All right, will this have a vertical shift from the parent function? Will this shift vertically? Why do you say no? That's right, nothing outside, no C, nothing's there. So if you look now at the graph, it makes sense. It went 4 to the left, and that was it. Is that absolute value graph narrower or wider than normal? What'd you say it was? Why? Why is it narrower? The M of 3. If you look at real closely at this graph, it is rising 3, running 1. Rising 3, and it's doing that both directions. Rise 3, run 1. Rise 3, run 1. Y'all fine with that? Okay. Turn to the first open page here. And real quickly, just make a large X and Y axis on that first page. And real quickly, graph this. Absolute Y equals the absolute value of X minus 1. Put a V graph on there where you think that would appear and how you think it would look. Somebody tell me what you think. Don't add a bunch of lines. Just keep it real simple. We don't want to take forever. Just an X and Y axis, just enough that we can see it. What do you think this V graph is going to do? How's it going to shift or adjust? What will be right 1? Vertex. Will it open up or down? Will it be fatter or narrower? Normal. 45s is So right there, that's, look at your neighbors, show them to your neighbor. Did anybody make one that looks similar to that? Okay. Now put that one on the same graph. You just did this one. Put that one on the same graph. We'll see how they look compared to one another. Somebody tell me where the vertex for this one is. Not quite. Is it shifted up or down? No. Is it shifted left or right? Yes. Which direction? No. Shifted right. Don't trust that with your eggs. There's only one time you'll see today you won't trust that. How far right? Is it 1 or is it 0.5? 0.5. I'm going to put a little line here to represent, this was 1. This will be 1/2. So there's my vertex. Should this new graph be skinnier or wider or narrower than this original one here? Narrower. It actually should rise, we'll just say rise 2, run 1. Well, I'm eyeballing it. It's a little more like this. It's a little narrower, if you can tell. It's narrower because of the M. Being able to recognize what these translations do to your graph will help you with your homework today. All right, let me go ahead and stop, and I'll give you that activity.